Innovative technology is all around us, and pretty exciting to talk about 3D printing and virtual reality and how we can apply those concepts to the process of bringing equipment to market. So we are very excited to have our very own Gary Casson. He's the engineering director of pneumatics and hydraulics for CNH Industrial, and he is going to share his experience and some insight on practical innovation and new technologies.
Thank you, Jody. It's my pleasure to be here. I'm an engineer. I love technology, and I love talking about technology. So hopefully I can share some things with you you'll find interesting and understand better how CASE brings technology to the market for you. There's 3 key aspects. First of all, we need to understand what's important to our customers, what's important to you. And once we understand that, it's a matter of converting that to a vehicle that's going to meet your needs. That's our commitment on reliability and performance. And then I want to talk about innovation, which is a key aspect to driving the technology that is important to you in your vehicle. So value, let's talk about value first. So it's really about how you dig more dirt, you use less fuel, you automate the functions that you're doing all the time, or things that are more difficult to do. We are incorporating automation into our vehicles. We want to increase the reliability. We want to make it easier to maintain. And ultimately, because you're going to spend a lot of time in your vehicle, or potentially a lot of time in your vehicle, we want to make it as comfortable as possible. So all of those things are what we try to incorporate into every one of our designs. The CNH development process has 6 steps. And if you were a CNH employee, you'd go through a whole day training class on how to develop products. I'm not going to bore you with that kind of detail. I boiled it down to a few slides, and it's a pretty simple, straightforward process that I think you can understand and appreciate how we make sure we're delivering the vehicle that you want. First one is we have to understand what the vehicle has to do. Then we have to drive the technology that is needed in that vehicle. We evaluate multiple options because many times there's more than one way to meet a customer need. We design that vehicle based on what we decide is required, and then most importantly, we validate that vehicle is going to meet your needs and it's going to do it over the life of the vehicle, and then finally we go into production. So let me go a little bit deeper on each one of these. So the first part is understanding the customer value. So shows like this are a great way that we get feedback from our customers like you. We listen to what you like or don't like or what you want to see in a future vehicle. We also look at industry trends. Do you want to move more dirt? Are you looking for a bigger machine? Is the trend towards lower noise? Are you working in a residential area? We need to understand what the trend is in the industry so we can incorporate that into the vehicle. We also look into adjacent markets. The nice part about CNH is we have sister companies that are in automotive, they're in truck, Ram, even Ferrari, and Iveco are all part of our sister companies. And we can look to them on technology and products that they're using and leverage them into the CASE construction vehicles. And finally, government regulation. Sometimes there's regulations on emission requirements. There's also sometimes on safety requirements. We want to make sure our vehicles are meeting those so you can use them into the market. Step 2 is driving the technology. And so we do it through a variety of ways. Most importantly is we develop the technology internally. But we don't have the bandwidth, we don't have the expertise in every component that's used in the vehicle, so we also rely on our suppliers and our technology partners. And so we want to make sure that every component that we have in our vehicle is the best available. We also work with universities. Universities are a great way to develop fundamental science, if you will. Not so good at applying that technology to a vehicle because they really don't understand the customer need, but a great place to develop fundamental technology that will benefit us as a company and ultimately you as a customer. And also a great place to get workers. So if we're working with the universities, they get familiar with our products and our processes, and they're more productive as employees when they start for us. And then industry associations. I'm going to talk about one example, CCFP, Center for Compact and Efficient Fluid Power, that we recently partnered with on Project Aiming. Let's talk about how we evaluate all these different options. Like I said before, there's more than one way you can solve a problem. There's more than one way you can meet a customer need. And so we have to do a trade-off to understand which is the best one. And probably the best way we have is to do a cost benefit. Because the last thing we want to do is add a whole bunch of stuff that's going to add too much cost that you're not willing to pay for. Only if it adds more value than it costs are you going to buy it. So that's a very important aspect. And sometimes these technologies are difficult to quantify. You can't put them in words. We have to build a vehicle so you can test it and get a feel for how does it really perform. And so mules are one way that we do that, or demonstration vehicles, technology vehicles like the combination dozer and skid steer loader or compact track loader that we have over to my right. And then probably the tool that we use the most often is 3D Reality Center. So 3D reality is pretty common these days. You can even get it on your mobile phone. But CNH or CASE has been using it for over 12 years, and it's a great tool that we can evaluate designs before we build the first part. It saves us a lot of time, and it allows us to accelerate our development process and get you the product sooner. So this is a video that we created. This would be a typical design review. We have a special grabber. We can actually remove parts from the vehicle. It's a little bit distorted from our perspective, but the guy that's wearing the goggles, it looks real. It is correct in geometry, but we're a few feet behind him, or at least the camera is a few feet behind him. We get a little bit distorted perspective. You could remove access covers. You can look at how easy it is to service. You can look at wrench clearance, as he did a simulated wrench attachment there. We can do cutaways of the vehicle. He can walk right into the vehicle. You can, and you can get a perspective from inside the cab of the vehicle. You can look at the sight lines. You can see what it's like to operate the controls. So this is something we would use in the early phases of our development process. We have 11 of these virtual reality centers within the company throughout the world, and our largest ones are 14 by 25 screen, and the depth of the room is 20 plus feet. So we can model a full-size vehicle, most of our vehicles in full size. So it's a great tool that you can walk around the vehicle and get a perspective before you even build that first part. We do customer clinics sometimes with these virtual reality models, get their feedback. We can do visibility checks, we can do lighting, we can simulate nighttime, we can look at how bright are the lights when you're working, to the side, to the rear, to the front, even inside the cab. We have a lot of good capability there. We can check serviceability, we can check the styling. We can also do safety reviews. We can do manufacturing reviews. These are all different ways that we can use the Virtual Reality Center. This is a finished vehicle, and this is not a real photo or a real video. It is a virtual video, and you can see that the detail of this vehicle is I would say almost unbelievable. You can go inside the cab. You can look at the controls. Even the mirror is showing a reflection of what you would see in the position of the mirror. We can create any environment we want. This happens to be a generic construction site, but we can make it daytime, we can make it nighttime, we can make it raining, we can do whatever we want. We can zoom in on the controls, give customers a perspective what it would look like in the real vehicle before this vehicle is made. Just zooming in under the underneath side of the control, you can see there's 3 different buttons there. We're going to back out of the cab now, and we're going to look at the serviceability of this vehicle. Open the access cover and check the fluid levels. You can also walk to the back side of the vehicle, open the hood, look at the accessibility of the oil filter, the dipstick, the clearances for different things, for servicing. All of this, again, is virtual. This is not a real vehicle that we videotaped. We use these models for in other ways. We use it to analyze the design. We do finite element modeling, stress analysis, deflection analysis to make sure it's got the strength that you need for it to work, and also to make sure it's got the right stiffness. The last thing we want to do is have an arm that is like a banana or rubber and deflects under load. We can make sure that we have the stiffness and the rigidity that we need. We can evaluate the cooling, not only for the engine and the hydraulics, but also the cooling and the heating that is inside the cab. We can simulate the efficiency of the vehicle. We can look at the engine. We can look at the hydraulics. We can look at the whole vehicle and estimate the fuel savings or the fuel consumption or the cycle times before we build that vehicle. Next, we validate that design. We want to make absolutely sure. Our modeling tools are pretty good, but ultimately they're not perfect. So we do physical testing. We literally run hundreds of tests on every one of our vehicles. We run tens of thousands of hours to make sure it's going to deliver that level of performance over the life of that vehicle. We do it under real life conditions. We do it inside the desert, simulating how, is the cab keeping the dust out? Is the filtration system for the engine have the capacity to run for an extended period of time in these dusty conditions? So we're evaluating real life conditions that are important to our customers. And we're also doing real operations. The bottom right is where they're doing a basement dig. We do some very interesting tests, and I'm just going to share a couple of them with you that I think you'll find interesting. The lower left is we're actually using pneumatic cylinders to actuate the joystick. We want to make sure that joystick is going to be good for the life of the vehicle, and we'll run thousands of cycles just to make sure it's going to perform the same as it did in the beginning as it does at the end of its life of the vehicle. On the upper right is a drop and catch, and we're simulating how much or testing how much load could be applied to the arm and the front axle. The bottom one, bottom right, if you think it looks like you're seeing things and that wheel loader is flying, it actually is over a foot off the ground, and it is a test that we run, and I'll show you how we do that in just a moment. So let me do the drop and catch first. And so we have a heavy load. In this case, it's steel plates. You can see how much the front tires deflect, and so we're at the tipping point of the vehicle. So it's a simple test, but an important test that we just want to make absolutely sure that all our analysis was done correctly. The next test is my favorite test to watch, not to be in the cab, and you'll see why in a moment here. So this is in real speed, and now it's going to repeat at reduced speed. So watch how much that back wheel deflects. The tire deflects almost up to the rim. It bounces over a foot off the ground and goes back and forth. And look at that operator bouncing around in there. I would not want to be in there. Maybe you would, but I wouldn't want to be in there. And it's all about making sure that rear axle, the rear frame is strong enough for the most severe conditions. Are you likely to do that in the field? Probably not very likely. But we want to make sure if it does happen, it's going to survive. So now we've made sure that the vehicle meets your needs, and now we can go into production. You can see many of those vehicles here this morning, and ultimately we're delivering the value that you were expecting in the beginning. My favorite part is innovation, and how do we drive innovation to make sure that we have the best available technology in your vehicles. So the one example I want to talk about is Project Amy. That was the one we partnered with just recently. It's at the show. If you want to go and see Project Amy, it's down in the Technology Pavilion just outside of South Hall. And it's been a great, in fact, it's been probably the most popular vehicle to see here at the show. We had over 32,000 people see this additive manufactured excavator, and CASE was a key part of that. And I'll tell you a little bit how this project got started, and then ultimately what was the result of that partnership. So it was a collaboration with multiple organizations. The first one, which is the Center for Compact and Efficient Fluid Power, or CCFP, and that's the organization that CASE belongs to. Oak Ridge National Labs is a Department of Energy organization that focuses on saving energy. And you may ask, well, why in the world would the Department of Energy care about manufacturing? But roughly 30% of the energy consumed in the US is producing stuff. And the Department of Energy is looking for ways to save fuel or save energy. And so they focus on finding more efficient ways to make stuff and faster ways to make stuff. So we partnered with them on this project. And then also the AEM, who is a sponsor of this show, once they found out what we were doing on this vehicle, they wanted to be part of it, and they made it part of this new technology pavilion and really helped promote it at the show. So let me just tell you a little bit more about the two organizations that you probably never have heard about before. CCFP, first of all, it's a engineering research center that was started by the National Science Foundation, and its focus is on improving fluid power. A large percentage of the energy that is created off of our diesel engines goes into hydraulics, and if we can improve the value or the efficiency of the hydraulics, the compactness, the noise level, the environmental impact, it makes our vehicles better, and ultimately it's better for our society as a whole. CCFP is an industry-government partnership. The National Science Foundation, the Department of Energy are partners with us. There are 7 universities that were part of this center originally, and now there's a couple more. There's about 50 companies, some OEMs and some Tier 1 and Tier 2 suppliers, and of course CON-AGG is a member of this organization. So how did this project start? So we had a meeting at CCFP, and part of that meeting is we visited Oak Ridge National Labs. Oak Ridge National Labs has a long history developing technology. It goes back to during World War II when it was kicked off in Oak Ridge, Tennessee. And it's a public-private partnership. They have roughly 50 projects going at any one time. And their goal is to reduce risk and accelerate technology in the area of manufacturing. So we visited them in October of 2014, and they showed us this car that they had made in less than 1 week's time at the ISTM show in Chicago. It is a carbon fiber car. There was no components, or there was no frame, there was no fenders, there was no hood at the beginning of the show, and they actually built it up at the show. Everyone could walk around and see it. And at the end of the show, they bolted on the wheels, bolted in the engine, and they drove this vehicle off the show. And so we were really impressed and excited about that technology, and we said, well, could we do this in the off-highway? Could we do this in the construction market? So their first application was in the carbon fiber, which is a type of plastic, so they wanted to go into the steel. So Project Amy was born, just another vehicle that the Oak Ridge Labs created just for interest. They unveiled it at the Detroit Auto Show. That is also a carbon fiber car that they built at the show. And you can see this is a little bit more finished than the dune buggy type thing that there was at the ISTM show. An excavator is very complex and very big, so we had to break it down to some components that we would convert to additive manufacturing. We selected 3 different components, 3 different materials. The cab would be out of carbon fiber, the same as those 2 cars that we saw earlier. The heat exchanger would be aluminum. And the arm and the boom, initially we're going to make both out of steel, but we kind of ran out of time, or I should say Oak Ridge Labs ran out of time, and they were only able to do the arm before the show. So this is the cab team. It was actually a student competition. There was 4 student teams, university teams that applied, and industry was the judge. We also defined what the requirements were from a safety perspective. What were the loading requirements? Since we're starting with a case excavator as the base vehicle, we knew what the loading requirements were. We knew what the customers wanted, the safety requirements, and we shared this with the student teams so they could design using this new material and making sure that it would met all the safety requirements. And also we were challenging them to improve the aesthetics to make it interesting. And you can see that they have some creative or interesting styling that's in the cab that is not in a typical steel cab that you see today. The winning team was from University of Illinois in Champaign, and they got $2,000, or the students got $2,000, plus they got the ability to come to the show. Two of those students are here at the show today, and if you go over to the Technology Center, you can talk with them and see what they learned and how they benefited from partnering with CASE. The next part is the heat exchanger, and again, it's made out of aluminum. Their focus was improving the efficiency. How do you make it smaller in a very space-constrained vehicle? They looked at different ways to change the internal geometry, the external geometry to maximize the heat exchange. And so you can do things with additive manufacturing that you cannot do with traditional manufacturing techniques. This particular part took about 7 days to build. I didn't mention it before, but the cab only took a half a day, so a very fast process with the carbon fiber. And then the steel parts, the arm and the boom, the goal was to make them lighter so you could dig more dirt. You could improve the energy efficiency. So if the arm is roughly 400 pounds, and so if you can reduce that by 50 pounds, that means you can carry 50 more pounds in the bucket without increasing the weight or the size of the machine. So there's some real advantages to making the arm lighter, but of course you wanted the same stiffness and strength as we have today. This is literally welded up from a plate all the way to the 7-foot length. For those of you that have done welding, you know that if you weld something, you tend to get a lot of distortion. And so that's where the technology is how do you minimize the distortion? And Wolf Robotics, along with Oak Ridge National Labs, was able to develop a process where over the entire 7-foot length, the variation in location or size was within 50 thousandths, which is really incredible on something that is 7 feet long. This is a fast buildup of this arm. It took roughly 5 days to make it. And it's literally building weld on weld. One of the things we also were able to do is incorporate the hydraulic lines that are for the aux circuit. One of the hazards that you have with an excavator as you're digging around rocks and concrete is if you bump the side of the arm, you can damage the hydraulic lines and then you get a leak. By integrating it into the arm, it makes it much more durable and less likely to have a leak. So that's something you can do with additive manufacturing that you cannot do with traditional manufacturing processes. This is the final excavator. Again, it started with a CASE 5.5-ton mini excavator that they upgraded in the arm, the cab, and the oil heat exchanger. So what did we learn? First and foremost, we learned that additive manufacturing is a great tool it gives the designer a lot more flexibility. It gives us the capability to do things that are not possible with traditional manufacturing processes. And maybe most importantly, it shortens our lead time. A typical prototype part will take anywhere from 2 months to 6 months. And with this process, all of those parts were made in less than a week. So shortening the development time. In most cases, we did not need any tooling, which is a big cost savings, especially for low volume parts. And where do we see this technology being used? It's going to be more on the low volume parts, the number of parts in development phase, or maybe end of life cycle test or end of life cycle component. Let's say you have a 20-year-old machine and you need a replacement part. The tooling has worn out, it's no longer available. With additive manufacturing, you could make that part, even the tooling is wore out. We also learned that partnerships are a great way to advance the technology. Universities, again, are good for the fundamental science, but also a great source for future employees through the students that are working on these projects. Industrial organizations provide a way to accelerate the development. We can pool our resources, excuse me, develop standards that can benefit the industry as a whole. And then finally, when our needs align with the government needs, in the case of the Department of Energy, where they were trying to improve the efficiency of manufacturing, it's a great way to accelerate technology and get technology in faster. And of course, this is all about driving innovation into our products. So, in summary, first and foremost, it's understanding the value to our customers, making sure we understand what's most important to you, to incorporate that into our design. CASE has the commitment that we will make sure that it's rugged and reliable and delivers what we say it's going to. And finally, innovation. Innovation is a key thing that adds value, and CASE is developing innovation or technologies internally, but also partnering with outside companies. And our goal is ultimately to make CASE your preferred brand. So thank you very much for your time.
Very good. Thank you so much.
All right, thank you for your time.